Hello, today we'll discuss about some numerical problems related to position vector or radius vector. So first we'll discuss what do you mean by position vector. So at first, position vector is represented by r vector, which is function of x, y and z. So if you have a linear coordinate system, some x, some y coordinate, and you can just think about some z coordinate, so perpendicular to this. Now any point on this three-dimensional coordinate system is represented by some point P, which will be the representation with respect to x, y and some z. Now the vector with respect to origin, where the x, y, z values are 0, is represented by r vector. This is known as position vector, or sometimes it's called the radius vector. Now we're going to find some operators related to position vector. So the first one is given as divergence of position vector, divergence of r. What is divergence? It's a space derivative. So r is represented by x, y and z, and we are differentiating with respect to x, y and z. So we are differentiating with respect to x, so this gives you 1, along y this is 1, and along z this is 1. So add all of this, this will give you 3. So if you have to find the divergence of position vector, this is 3. Now if you want to find the curl of position vector, so the curl operation, we all know this is in the form of a matrix. So now if you want to find curl of x, y and z direction, so f here, f or r is represented by I, x, I, y and I, z, and fx is represented by x, fy is represented by y and fz is represented by z. So the curl is given as, so the first we are going to consider this section. So when you are finding with respect to I, so obviously this will be the operation between this direction minus of this direction. So this is f of divergence, del of z over del of y. So this is z, and again this will be del y, del of z, because this is y. Now the next will be, we have to block this second column and we are going to operate diagonally. So this will be del of del x over z, this is z, and del of del z over x, this is x. And there will be the third one with respect to k. So when you are operating over k, so obviously this column will be blocked and we have to operate over this and this direction. So this will be del del x over y and del del y over x. So you have this one. Now see, so everywhere where you are differentiating with respect to different value, when you are differentiating with respect to y, you got z. When you are differentiating with respect to z, this is with respect over y. When you are differentiating with respect to x, over z. So everywhere you got 0. 0 plus 0 plus 0. This gives you 0. So when you are finding curl of a position vector, this gives us 0 in the system. Now we have a little bit of complicated factor. Here we are trying to find the divergence over r vector divided by r cube. So to have the complicated system, to simplify this complicated system, we are going to consider along 3 different components. So the first we are going to write it for the x component. So r is a function of x, y and z. Okay. So now we are writing x component as x into x square plus y square plus z square to the power minus 3 by 2. Because r square is represented as x square plus y square plus z square. So r to the power 3 can be simply given as, so r can be represented as square root of this factor. So when you are trying to find r cube, so r cube is given as this factor to the power 3, and you have a square root, so square root is given by 3 by 2. So this is written as 3 by 2. And here obviously you have a minus sign, so this is in the numerator part, so yeah, this one there will be a negative sign. Now we are just try to find with respect to x component, so differentiation with respect to x over this x component. So this is x into x square plus y square plus z square to the power minus 3 by 2. So again, when you are differentiating this one, this is in the form of a into b. So first x will be taken as variable and this factor will be taken as constant. So when you are differentiating with respect to a, this is 1 and this factor remains. Now here we have next part, we have what you have to do, we have to take x as a constant and this factor as a variable. So when you are taking it as a constant, this is x, and you are differentiating with respect to this factor. Y and z, they are constant for this, so they will be as it is. And when you are differentiating over x square, okay, so this will be 2 of x, okay, and there will be 3 by 2. So 2 of x we can taken out and the whole factor is there, x square plus y square plus z square to the power minus 5 by 2. So again this will be minus 3 by 2 plus of 1, minus of 1. This is minus 3 by 2, the power will be minus 3 by 2 minus of 1. So this gives you minus of 5 by 2. So after simplification along x you have this particular factor. Now comes for y, the same thing will be repeated. Here we have x, then we will get y, and then we will get z for this one. So when you are differentiating with respect to x, you got this factor. When you are differentiating with respect to y, you got this factor. And when you are differentiating with respect to z, you will get this factor. So obviously we have 3 components together, you need to add all of them. So the divergence of r by r cube can be calculated as this particular thing. So this will be r cube, r to the power minus 3, this is common, so you can take it common. So what is left? There will be 1, 1 and 1 for all 3 cases. This gives you 3. Minus of 3, 3 is over there, 3 into x square plus y square plus z square, x square plus y square plus z square. And you have r to the power minus 2. Because every time you got this one, you have r to the power minus 2 term. Because you have x, here we will get y, here we will get z. So it's r to the power minus 2. X square plus y square plus z square, obviously this is r square. So r square into r to the power minus 2, this gives you 1. So what you have? R to the power minus 3 into 3 minus 3. So 3 minus 3, this is 0. So if you want to find r by r cube divergence of this factor or this function, this will obviously gives you 0. Now if you want to find that phi, some phi is given as x square plus y square plus z square. So one can just think about what is this x square plus y square plus z square. So this is given as r, the position vector is x, y and z. So the r square can be given as x square plus y square plus z square. So if you have r square of this form, so one can simply write, r is equal to x square plus y square plus of z square. Okay, so this is r. Now you have to find the gradient of phi. So you need to find gradient over x square plus y square plus z square. So if you want to find the gradient over this thing, you will have d dx, d dy and d dz. Actually when you are differentiating over x, so you need to have the phi over there. So but here only x is variable, y and z they are constant, so they will be zero. After differentiation this will give you 0. When we are differentiating with respect to y, then this factor is only variable, x and y, x square plus y square, this is x square and z square, they are constant. When you are differentiating with respect to z, then x square and y square, they are constant. So after differentiation you will get 2x, 2y and 2z. Take 2 common, you will get I of x plus I of j plus I of k. So this obviously give you 2 into r. So when you are finding that phi means it can be given as grad over r square. Okay, grad over r square. Grad over r square, this is twice of r. This is the relation what we are talking about. Now same problem we will have. Here we have phi or r square equal to x square plus y square z square. Now we can have a relation that you have r where r is given as, we need to find the r. R is over when r square is equal to x square plus y square z square. So r is given as under root x square plus y square plus z square. You need to find the gradient. The same problem, same type of problem, we need to differentiate with respect to x, y and z. When you are differentiating with respect to x, obviously y and z, they are constant. So you need to differentiate only over x. So this is x square. So when you are differentiating over x square, this is twice of x. And under root of this thing, obviously there will be half of this one. So half will be cancelled out. There will be x divided by under root x square plus y square plus z square. Same thing happens for the y. It is also for z. So there will be x plus y plus z. So this is I of x, I of y, I of x, j of y and k of z under root x square plus y square plus z square if you take common. So this gradient is given as r divided by this square. So this can be given as, this is simply represented by I tau. Now we'll have another one, another form of this thing. Okay, so if you want to find that under, which is 1 divided by this factor, here we have calculated square root of x square plus y square z square. Now here we try to find 1 divided by x square plus y square plus z square. So you need to find the gradient of this thing. Again the same procedure, we need to differentiate with respect to x, we need to differentiate with respect to y, and we need to differentiate with respect to z. So you have an under root of this thing. So when you are differentiating this one, so this will be, the power will be half plus of 1. So this gives you 3 by 2. Now when you are differentiating over this factor with respect to x, this gives you twice of x. So obviously there will be twice of x. And as we are differentiating over this thing, so there will be half multiplied with this. And you have x square plus y square and plus z square will be there. This is for x component. Same thing will happen for y component. This is twice of y multiplied with half factor. And then there will be for z. So this is given as I of x, and there is a minus sign. This is under root 1 by under root of this thing. So there will be one minus sign. So the minus can be taken common. So when we are taking common minus, so this will be I of x plus j of y and k of z. So obviously this will give you minus of r. And what is left over there? This is x square plus y square plus z square to the power 3 by 2. And we know r square is equal to x square plus y square plus z square. So this gives you r cube, r divided by r cube, and minus sign is. So this factor is equal to r square into 3 by 2. So 2 into 3 by 2, the power will be 2 into 3 by 2. This is to the power 3. And the last one, again we are finding some phi, where phi is given as log of r. Remember it, here we are just making it complicated. This is log of r, and another case this is given as 1 by r. So first just take it log of r. So what is r? R is equal to I of x, j of y and k of z. So what is mod of this thing? Mod of r is equal to, actually this is r square. So when you are taking mod of r, this is under root of x square plus y square plus z square. So if you are taking it log, so log, this is x square plus y square plus z square to the power half. So this factor is x square plus y square plus z square. Okay, so whole to the power half. So if you are taking it log over there, so half will come out here. So this is ln x square plus y square plus z square. Now you have to find the gradient over this factor. Gradient over this factor. Again, the idea will be same as earlier. We need to differentiate it with respect to x separately, y and also for z. Again, when you are differentiating over this thing, we are differentiating over x square, and y and z, they will be taken as constant. So everything will be similar. So when you are differentiating with respect to x, so this will be 1 by this factor x square plus y. We know when you have some factor ln, so when you are differentiating over ln, say you are differentiating over x square plus y square plus z square to the power half will be taken here. Now we need to differentiate over this factor because half is a constant term. So when you are differentiating this one, obviously this will be differentiated over x square. So this gives you twice of x. Now when you are differentiating over this whole ln factor, so this will give you 1 by x square plus y square plus z square. Same thing is happened for y. So we are differentiating over y square. This is twice of y, and other factor is x square plus y square plus z square. And same thing is happened for z. So now take common. So all are having 2 over there multiplied with half. So half will be cancelled out. The 2 factor will be cancelled out. So what is left over there? I of x, j of y and k of z. So this gives you r vector. And x square plus y square plus z square, this obviously gives you r square. Now the last factor, here we need to find 1 by I, gradient of 1 by r. So again we know what is r. R is x square plus y square plus z square. So obviously this can be written as x square plus y square plus z square to the power minus of half. And we need to differentiate with respect to x, y and also with respect to z along 3 different directions, I, j and k. So when you are differentiating with respect to this, what this will give you? Minus of half will be taken out. And obviously this will be differentiating with respect to x square. This gives you twice of x. And 1 by this factor. X square plus y square plus z square. And this will be minus of 3 by 2 of 1. So minus of 3 by 2, minus of half, minus of 1. This obviously gives you minus of 3 by 2. We are differentiating this one. Same thing is happened for y axis. Here we are differentiating with respect to y square, so this gives you twice of y. Half, minus of half will be taken out, the power will be taken out, and this will be 1 by x square plus y square plus z square, and the power will be minus of half, minus of 1 as we are differentiating this one. This is minus 3 by 2. Same thing is happened for y, z. So x, y and z differentiation is there. So 2 will be cancelled out. So what will be left? Minus. You can take minus common. So this will be I of x plus j of y plus k of z. So if you take it common, so this gives you minus of r. And what you have? X square plus y square plus z square to the power 3 by 2. And we know r square is equal to x square plus y square plus z square multiplied with 3 by 2. So when we are multiplied it 3 by 2, 2 will be cancelled out. This gives you r to the power 3. So we have discussed about the idea about position vector, basic idea about position vector, and some operators related to position vector. Thank you.